All right, here we go. We got 5.4 right here. We got some indifference identities here, and pretty straightforward. We're just going to follow these formulas here. And there's a couple of different variations the way I can ask you these here. Kind of the big thing here is we can, sine of 15 is not on our unit circle, but if we can figure out the, two things that add up to 15, we can kind of, in a way, I guess, expand this out and actually figure out the exact value of sine of 15 using these formulas here. So you can do that in terms of degrees and radians. Sometimes we can take something that's already been expanded and condense it down into one expression and then solve. So we'll have a few of those. Some of them they're not going to actually give you things on the unit circle, so we can do that here in a second. And I might modify that question here in a second. Sometimes you'll get some where you can like verify or even solve equations using some of our identities that we're looking at here. So a lot of fun stuff coming up here. So let's take a look here at the first one here. Find the exact value of the trig function or the trig expression right here, sine of 15. So what I need to do is figure out two things that I can think of that add up to 15. Typically, you'll want to do, like I'd say a good rule of thumb is either um, add or subtract 45 degrees or pi over 4 from your answers. So, like, on the 15 right there, you could go and say, well, okay, that could be like maybe like 45 and 30 actually. Yeah, so if you were to add 45 to that, you would go and then get 60 there. So you could go write this like this right here. This is what I'm trying to say. Sine of 45 and then minus 30 right there. So if you actually subtract those two right there, 45 minus 30, that actually gets you 15. And then we're going to label this here with a U and a V. And then we're going to use this sine formula that's got sine of an angle minus another angle right there. Okay, that calls for sine of U. So in our case here, sine of 45 degrees. And then cosine times cosine of 30. Okay, and then you'll do minus, you'll keep the same sign right there, and then that'll be sine of 30 degrees. And then cosine of 45. And then I have off screen here what that's going to come out to in just a second here from a unit circle. So sine of 45, that on the unit circle is the y value. It's root 2 over 2. Cosine of 30 is going to be square root of 3 over 2. Okay. The other side over here, sine of 30, that's actually going to be 1/2 on the unit circle. So we'll do minus and then 1/2 eventually. And then cosine of 45, that'll be root 2 over 2. And then when you're multiplying fractions, you multiply the numerators and you multiply the denominators. So that'll come out that right there. And then I guess one step here, it doesn't really make it that much different here, but you can combine up the numerators. Or really, you can't even combine them, but I guess you can write them together like that. And I think most of the times the teachers like you to leave it like that right there. Square root of 6 and square root of 2, since they don't have the same thing inside the radical, you can't really combine those up there. So that is doing one of those there in terms of radians, or I'm sorry, in terms of degrees. And then now we got radians coming up here. So like I said here, a good rule of thumb, especially when you don't know, like 7 pi over 12, we don't really have a spot for that on our unit circle. So what I'm going to do is off to the side, I'm going to take away pi over 4 from that, and then see what that comes out to. And then I'll just say, okay, these next two things add to, I guess, 7 pi over 12. So let me show you what I mean here. I'm going to go off to the side, this is scratch work here, and subtract pi over 4. And I apologize for my handwriting, I don't have an Apple pen here today, so just rolling with it here. When you subtract fractions, you need a common denominator, so that pi over 4, I need that to be a 12 in the denominator, so I'm going to multiply top and bottom by 3. And that is going to come out to 4 pi and then over 12, which actually reduces down to pi over 3. So add or subtract pi over 4. So now what I know here is pi over 3 plus pi over 4 actually comes out to 7 pi over 12. And I'm going to go ahead and write that out here. I'm going to write tangent. And then let's see here, my notes here, I put pi over 3 first. Got some filled in notes here to the side. And then that'll be plus pi over 4. All All right, and then this is going to be your u, and then this is going to be your v, and then we're going to go up to the tangent formula, which is up here, top left. That uses, the plus right there. So we'll go tangent of pi over 3, okay, and then plus tangent of pi over 4, and then that'll be all over, and then this will be 1 minus, and then the product of these here, tangent of pi over 3, and then tangent of pi over 4. Okay. And then from there, after we do that there, we will start to simplify here. Tangent of pi over 3, that's on the unit circle. That would actually be root 3 over 2 over 1/2. We're going to go ahead and say that that's square root of 3. We're kind of assuming that you already are comfortable with the unit circle and evaluating. Remember, tangent's your y value over your x. Tangent of pi over 4, that would be root 2 over 2, and then divided by root 2 over 2, which would actually come out to 1. Cleans itself up real nice. Down in the denominator, we're going to go and write 1 minus, and then basically those same values right there multiply together. Square root of 3, and then times 1. Right, I'm just going to clean this up just a hair. This will be 1 minus square root of 3. Okay, now, you could probably get away with leaving it like that, but some teachers want you to rationalize the denominator. So I'm going to go ahead and do that. Usually it's a good idea to do that there. So I'm going to multiply top and bottom here by the conjugate of the denominator. That's our technique to rationalize or get rid of radicals in the denominator of a fraction here. Okay, and then basically you got two FOIL problems here. 1 times 1 in the denominator, I'll do that first. So 1 times root 3 will be positive root 3. 1 times negative 3, or negative root 3 would be negative root 3, which we're kind of forcing those to cancel out. That's why we're doing a conjugate. And then square root of 3 times negative square root of 3 is negative square root of 9, which we can go ahead and say here in a minute that that's regular 3. Then in the numerator, we'll do the same thing. We'll do square root of 3 times 1. We'll do square root of 3 times square root of 3 right there, which is square root of 9 again, which will be regular 3. Do the insides there. That'll be 1 times 1, which is 1, and then we'll have 1 times square root of 3. So just square root of 3. Okay, I'm going to go ahead and move this up here a little bit so I got some room to work with. Okay, and then from there, all these square root of 9s you can say cancel, or, well, not cancel. I guess you could say it's, in the denominator, 1 minus 3. You got 2 of the root 3's, and since they have the same exact thing in the radical, you can actually combine those to 2 root 3. And then basically you're going to have 3 for the square root of 9, and then plus 1. That's going to come out to 4 right there. Okay. And then denominator, you can go ahead and write as 2 root 3, and then plus 4, and then over negative 2. And since all the numbers outside of the radical are all divisible by 2, I'm going to go ahead and do that. I'm going to divide them all by 2. And actually, I'm going to divide by negative 2. It'll be negative 1 root 3. And then that'll be minus 2 right there. Okay, and you could write that in any order. You could also write negative 2 and then minus 1 root 3. So that one's a little hard. It's not hard to get to this point right here, but the rationalization's a couple extra steps. Now, sometimes, when you got cosine and sine, it's a little bit easier because you don't have fractions, and therefore you won't have to rationalize. So, not too bad there. You could do extra practice problems there if you want to try those there. We'll move on to the different type of examples. Sometimes, instead of, doing the actual exact value, sometimes I'm going to give you something like this here, and we're going to have to condense it into one trig function here. So, it's kind of like your u and your v here. And it looks like it's being added right there. So if I go and kind of look backwards here, the one that's got tangent in the top and it's got added is this one right here. So we just need to rewrite this as tangent. And then this will be the same thing as tangent of 32 plus 13. Now 9 times out of 10, they're actually going to give you something here that when you combine, you can actually simplify this down. You can say, oh, that's a tangent of 45. And of course, tangent of 45 right there, that's going to be root 2 over 2, and then over root 2 over 2, that's going to come out to 1 right there. And that's how you do that problem right there. So some of those are actually kind of short and sweet. They're not too bad there on that, I guess. So that is that there. Let's look here at this one here. Let me scroll to this on my notes. Okay, so we're going to simplify this expression here. And notice here you got these three x's here. So got the x and the x. So basically, in a way, this is already has the sine formula, I believe, working here. Or actually, no, it's sine and then cosine and cosine. Oh, yeah, interesting here. Oh, okay, I see where, yeah, I was trying to think here. Notice the formulas, they don't have where you got sine and then cosine and cosine, unless you're doing something like this, or I guess like this right here. But the sines start first, so we're going to have to do this weird little manipulation trick right here to get around this here. So what we're going to do on this one here is I'm going to actually divide everything by -1. There's really two expressions here, so I'm going to basically factor out -1. I'm going to go -1 and then factor that out. And that would be, of course, negative sine x and then sine 3x. And that's all one term, so you only put negative out there in front once. And then that'll be plus cosine x and then cosine 3x. And then I'm going to just strategically rearrange it to where it kind of looks like one of those formulas on the previous page. Cosine of x times cosine of 3x. Writing this down wrong here. And then, whoops, that should be plus after that. Or no, I'm sorry, minus after that because you got the negative sign. So minus sine x and then sine 3x. And that actually looks like one of our cosine formulas up above. Basically, our u is x and then our v is 3x. So now we can go and simplify this here. So if you follow the formula, I'm going to stop scrolling through to keep messing y'all up there. So this will be x and then plus 3x there. There's your u and then plus your v. So obviously it comes down to cosine of 4x when you combine up. And then you still got your negative out in front. And that's how that thing simplifies there. So sometimes you'll have something that's simplified down and you can actually evaluate. But since we got cosine of x or negative cosine of 4x there, you can't really do much there with that. But 1 and 2 there are good extra practice problems there if you want something pretty similar. Okay. Now this one's a little bit harder than what we kind of see on tests and quizzes. So what I like to do here is actually kind of modify this here to practice work in here on some of the other properties, the ones basically dealing with triangles. Because sometimes they'll give you two angles here. So let me just change this up here a little bit. Let's say it's sine of, let's do this here. Sometimes you'll see one like this here that'll say evaluate like sine of alpha and then plus angle beta or something like that there. I can't really do the beta symbol very well with my hands here. But so anyway, something kind of like that right there. You might see something like that. And then they're going to go off to the side here. And then they might even tell you like, sine of alpha is like maybe some type of fraction or something like that. Let's do like, I don't know, like 3/5 or something kind of like that, I guess. And then maybe like, I don't know, maybe they'll say like cosine of beta. Let's say that's, let me see if I can come up with another triangle. Let's go 5 over, let's do 5/13 right there. I think that should come out pretty good. So let's do something like this here, just to practice dealing with where you have to write your own triangles out here. I think this is a good alternate problem right here. So here's what I'm going to do. For sine of 3/5 right there, we're going to assume this is in the top quadrant unless they give us extra information. They could go and tell you maybe like maybe tangent of alpha is maybe greater than 0 or something like that. And then sometimes we'll say like maybe over here sine of beta here is greater than 0, and that would just tell you what quadrant you're starting in. So I'm going to just kind of make this problem up here to start up in the top right quadrant. So I'll go and do that here real quick, and then you'll just make your right triangle here, and then there's your reference angle. That's actually alpha, which I don't really care what the actual number is here. We're just going to use this to help us there. So, and then we'll go and say, okay, sine is 3, opposite, and then over the hypotenuse 3/5. And then we can go do Pythagorean theorem to go find that side right there. A squared plus 3 squared equals 5 squared, which eventually you're going to just get A is 4. Okay, and then this beta angle here, it's a different angle. And then let's go see what's going on here with this. Sorry, I'm getting sloppier as the night goes on, but well. So this will be 5 there. That's adjacent, by the way, adjacent over hypotenuse. So 5 over 13 right there. And the same thing, we'll do Pythagorean theorem to go find that side. And let me just spoil it here for you. It'll be 12. And then this will be angle, oops, not R, but beta. Okay, so then let's try this out here. I think the whole point of this problem, they wanted you to practice with the making your own triangles, I guess, here. So now they ask, okay, sine of alpha and then plus beta here. So the formula there for that's going to be sine of alpha, cosine of beta. And then let me double check here so I don't butcher this here. So that's sine and that was plus. Yep, so sine of the first. Okay, so the second one's cosine of alpha. And then sine of beta times sine of beta. Okay. And then from here, this is all going to be really just like fractions and then just using our calculators and stuff like that there. So sine of alpha, I'm going to go to my alpha triangle right here. And sine would be actually the 3 over 5, in which we already kind of knew that right there. So, okay, 3 over 5. Cosine of beta, we actually happen to start with that too. That was apparently 5 over 13. There we go. And then now we'll go over here, and now we'll do cosine of alpha, which that's going to be the adjacent over the hypotenuse. That's going to be the fraction 4 over 5. And then we'll go do sine of beta. Sine of beta here would be, let's see, that would be 12 over 13 there. All right, perfect. And then you're going to just multiply your fractions, and I think you kind of naturally get a common denominator here. So I'm making this up here on the fly. Let me figure out 5 times 13. I believe that's going to be 65. 5 times 13. Yep, 65. Perfect. Okay, and then we'll have 15 in the numerator. And you could, I guess, like go reduce your fractions, but I'm not going to do that here quite yet because they're going to naturally have a common denominator. Okay, I guess we'll get 48 over 65 right there. And then we can do the 15 plus the 48 right there. That'll get us 63 over 65, which I don't think reduces there. And that'd be how you do something kind of like that right there. So I think that'll be more like what you see on some like future tests and quizzes there where you make your own triangles. I think there's even a few homework questions like that. So I thought that would be a better question there to roll with right there. Okay, let's keep it going here. We can also use these identities that we've been learning here to actually verify. This is one of your cofunction identities right here. Sine of pi over 2 minus x is actually cosine. So we'll go ahead and expand it with sine. I guess we've been doing a lot with sine here today, but this would be sine. And then let's do pi over 2, because this is your u, and then this is your v. And then that'd be times cosine of x. And then there would be a minus. I'm just following the formula there. And then the next part would be sine of times sine of x, I guess, and then cosine of pi, and then over 2. And that'll be it right there. So, and then we'll go ahead and start to simplify this down here. You know what? Actually, I wrote it actually in a slightly off order, but it's actually it still comes out to the same thing. I think the formula actually here says cosine of pi over 2, and then sine of x. That was going to still come out to the same thing anyways. So sine of pi over 2 would be 1. So we'll have 1 times cosine x. And actually cosine of pi over 2 is actually 0. And then 0 times sine x, really, that's just going to be 0 right there. And then 1 times cosine is actually cosine x. And that's how you can actually verify one of your identities there. So that's going to be it there on that one there. We can even extend these ideas here. We can actually solve using some of these ideas of sums and differences here. So I think that happens here. I guess this is the last one here like this. So let's see what's going on with this one here. So we're going to find all solutions here. This is one of your cosine ones. And then the cosine one, just so I don't have to keep scrolling back and forth. Let me pull it up in my notes. Get caught up on this. Okay, so this will be, oh, and actually there's 2 of them actually. So this is almost like you do this twice. I'll color code it here so I don't mess this up here too bad. So let's see here. This will be first one. We'll do here in purple here. So the cosine formula, this is u and v. So this will be cosine of pi over 3. And then it'll be times cosine of x. And the next part will be minus, it'll be the opposite sign of this right here, minus sine of pi, and then over 3, and then sine of x. So that'll be that whole thing that's in purple there. This part here that's in blue, it's very, very similar there. Notice here that this will be, I guess, plus, and then this will be cosine pi over 3, and then cosine x. And then this one will have a plus instead, and then we'll go sine of pi over 3, and then sine of x. Just like that right there. Okay. Now, some of this is going to clean itself up here. Of course, you got the 1/2 over here on the other side, but cosine of pi over 3, that'll be 1/2. Here, I guess I'll keep it color-coded just so we don't mess ourselves up here. This will be 1/2, and then cosine x, and don't forget about the cosine x. We'll be able to deal with it here in a second. Sine of pi over 3 is going to be negative root 3, and then, or really it's root 3, I'm sorry. It'll be minus and then root 3 over 2, and then that'll be sine x. And then now we'll come over here. It's very, very similar. Cosine of pi over 3, again, is cosine of pi over 3. I think that's 1/2 again. We'll go 1/2 cosine of x. Okay, and then the plus, and then you're going to do, that'll be root 3 over 2, and then times sine of x right there. And then finally, right hand side equals 1/2. Now, what's kind of nice here about this is the root 3 over 2 times sines. You got one that's positive, one that's negative, so they'll cancel out. And then these guys here, you got 2 half cosines, so if you add a half plus a half, you'll get 1 full cosine x. Then now we just got to think about what angle gets you, I guess, 1/2 right there when you use cosine right there. And that means x is going to be, and I'll put it, I guess, in radians here. That'll be pi over 3. And that's just using your unit circle to look backwards. And then that'll also be 5 pi over 3. And then since they gave us an interval, they said don't look forever, don't do the plus pi n or plus 2 pi n. We can just leave it like that. And I believe that is it here for our lesson here today. Have a good evening.